All right, welcome back. We're going to talk about symmetry. So now we're talking about functions. Okay, so we have only now two different kinds of symmetry when we talk about functions. There's y equals f of x is even. Okay, that's one kind of symmetry we'll talk about. Okay, and that happens if f of negative x equals f of x. So typical examples for even is y equals x squared, y equals x to the fourth, y equals x to the sixth, and so on and so forth. Those are all even, okay? So even if you sum up, so if I have like y equals 5x to the 10th minus 3x to the fourth plus 2x squared plus 5, and when we don't have a variable there, we could consider that as like x to the 0. It's sort of implicitly understood. So all the powers here are even, 10, 4, 2, and 0. Okay, we don't care about the coefficients, the 5, 3, 2, or 5 there. We don't care what those are. We just care about the powers. Okay, so all even powers means the function is even. By the way, I wrote y here. Y is just another way of writing f of x. Okay, one of those implicit things that sometimes I may forget. All right, next, let's take y equals f of x is odd. Okay, if f of negative x equals the negative of f of x. And surprise, surprise, some examples are y equals x, y equals x cubed, y equals x to the fifth, and so on and so forth. So all the powers are odd. Now, if it's not written, if the power is not written, we understand that implicitly to be 1. Okay? So again, sums of these are also going to be odd. So y equaling f of x equals, let's say, 8x to the 7th plus 6x to the 5th minus 3x is odd. All odd powers the function is odd. Now, let's go ahead and let's take a look at something a little more like a rational expression. So let's take a look at f of x equals, let's say, 6x to the fourth minus 3x squared over 5x cubed plus x. Okay, now we're going to do this two ways. First, let's do it directly. So let's take f of negative x. F of negative x means, again, we're going to replace x by negative x. So we're going to have 6 times negative x to the fourth minus 3 times negative x squared over, oops, I should have written that one. That was supposed to be a 3. Sorry about that. Minus 5 times negative x cubed plus negative x. Okay, now remember, the even powers, when you take negative x to an even power, the negative numbers just become positive again, right? But if you take negative x to an odd power, you're going to get a negative back. So the terms in the numerators give us back our original expression. But the terms in the denominator actually change sign. Okay, so then that becomes 6x to the fourth minus 3x squared over negative 5x cubed plus x, which is the negative of what we started out with. That means that our original expression is odd. Okay, now I'm going to give you guys a little shortcut. So now, functions don't have to be even or odd. You might have functions that are neither. The one that I did before does not have symmetry. And I'm going to write it does not have even or odd symmetry because it might have some other crazy symmetry I haven't thought about. I'm not going to go into that. But if you have f of x equals, let's say, p of x divided by q of x, then you can actually look at just the pieces to decide whether f of x is even or odd. So here's how it's going to go. Even over even gives you even. Okay. Odd over odd gives you, surprise, surprise, even. Even over odd gives you odd, and odd over even gives you again odd. So let's take a look at our original expression that we had. Looking back up here, looking back here where I'm circling, okay, the numerator was even, all even powers. The denominator was odd, all odd powers. So that was even over odd, and that gave you odd. Let's take a look at this odd over odd case. Okay. So let's suppose f of x is p of x over q of x, where both p of x and q of x are odd. So what does that mean again? P of negative x equals negative p of x. Q of negative x equals negative q of x. Okay, so then f of negative x is going to be p of negative x over q of negative x. P changes signs, q changes signs, and so since you have two negatives, okay, divided by each other, they cancel out to give you p of x over q of x. And that's what you started with, f of x. Okay, so that means that this situation you have, if both p and q are odd, then your original function is even. Okay, and all of this is summarized by this information here. Okay, all right. That's it for symmetry. We'll come back with another couple of examples and then we'll call it a day.